Okay, welcome back. We're going to do another JNCIE-SP video. So we're working on CoS, huge topic, but it's just a lot of picky details. The main concepts really, I don't think are super difficult. It's just once you start combining them, you get so many different things you can do. It gets really complex really quick. So last video we did scheduling. We did the second video on that, so that is now complete. We're moving on now to queuing. Oops, so it looks like this didn't get renamed to notes. There we go. Okay, so let's start off the video the same way we'll start every video. Seeing what we've got for help apropos. Okay, so scheduling. Let's see here. Examples, priority schedulers. So, so we're actually not doing scheduling now. That's what we finished before. So I didn't change the name yet. We're moving on to queuing. Okay. Okay, so we've got something popping up. It's PIC queuing. Let's see if we've got anything. Okay, so we do have so this looks a little bit better. Queues. So we've got matches on queues and queuing, but it looks like the matches for queues are going to be more relevant. But we'll include both in the notes. Okay, so let's start. Okay, I think we can get rid of the things that aren't class of service related, or they might be related but aren't a class of service topic. Okay, so let's get started. Alright, so examples, configuring up to 16 forwarding classes. This section includes the following examples: configure 16 forwarding classes, configure 16 forwarding classes. So for FPICs restricted to 4 queues, map 4 forwarding classes to each queue. Restricted queues mapping 2 forwarding classes to each queue. For PICs restricted to 4 queues, if you map multiple forwarding classes to a queue, the multiple forwarding classes must refer to the same scheduler. Configuring a scheduler map applicable to an interface restricted to 4 queues. Okay, so on to the next help apropos, or help topic, help apropos match. PICs restricted to 4 queues. Some Juniper Series T-Series core router PICs, so this isn't a T-Series router, it's an MX series router, so perhaps this isn't going to be what I'm looking for. Yeah, so this is just about overriding the default setting of 4 queues. Oh. Okay, so yeah, this doesn't look like the best one, so let's see if the next one is better. Okay, so the next one is going to be default routing engine protocol queue assignments. Routing engine protocol queue assignments lists how routing engine sourced traffic is mapped to output queues. The follow caveats reply to routing engine protocol queue assignments. For all packets sent to Q3 over a VLAN tag interface, the software sets the 802.1p bit to 110, so that's used for IP precedence. For IPv4 and IPv6 packets, the software copies the IP type of service, TOS value, into the 802.1p field, independently of which queue the packets are sent out. For MPLS packets, the software copies the EXP bits into the 802.1p field. Table 9, Routing Engine Protocol Queue Assignments. Okay, so we've got a table where it will automatically be assigned. It looks like sometimes it's assigned to Q0, other times it is assigned to Q3. For link services, if link fragmentation and interleaving LFI is enabled, all routing protocol packets larger than 128 bytes, which is 128 times 8 bits, are transmitted from Q0. This ensures that VoIP traffic is not affected. Fragmentation is supported on Q0 only. And for adaptive services PIC, TCP tickle keep alive packets for initial session generated with stateful firewall to probe idle TCP sessions are sent from Q3. Okay, so that I could see that table being handy in the future if I'm confused as to what kind of traffic belongs to what kind of queue. Next help topic document we'll be reading is queuing parameters for the PIC families. Queue parameters on PIC families compares the PIC families with regard to queuing parameters and features. Table 13, queue parameters on PIC families compared. So we've got a queuing statement here for M320NT. So we're going to have MX series routers, but I don't think they're that too different from a M series router. But you can see we've got this chart here. This one's not quite as useful as the other ones, but I think I'll leave it in my notes, even though it is for M and T series routers, and the test will be on MX routers. Alright, so I think it's time for Google search. So we'll do Juniper CoS queuing. Okay, so understanding CoS output queue schedulers, that looks like a good one. We've also got defining. Okay, so this is going to kind of overlap because it looks like scheduling and queuing are very much related to one another. Okay, so let's understand the CoS output queue schedulers. And I did read this whole thing before, so I'm not sure if it's going to be good to read it again, I guess. Okay, let me read this chart here. So we've got a table of output queue scheduler components. On the first column, we've got output queue scheduler component. So for instance, buffer size, and then we'll have a description of that. So I think this will be useful because we'll get a description of each queue scheduler component. So the first one is buffer size, and this sets the size of the queue buffer. The next one is drop profile map, and it maps a drop profile to a loss priority. Drop profile map components include drop profile, sets the probability of dropping packets as the queue fills up. Loss priority sets the traffic loss priority to which a drop profile applies. Next one is explicit congestion notification. Enables explicit congestion ECN on the queue. And then priority sets the scheduling priority applied to the queue. Shaping rate sets the maximum bandwidth the queue can consume. Transmit rate sets the minimum guaranteed bandwidth for the queue. Extra bandwidth is shared among queues in proportion to the minimum guaranteed bandwidth of each queue. Okay, so we've got some more here. These are other scheduling components. I'm not sure why they need their own table. Oh, maybe because they're not outputs. They could be input as well. But the first one is a forwarding class, and it maps traffic to an output queue. Classifiers map forwarding classes to IEEE 802.1p, DSCP, or EXP code points, depending on if you are sending, depending on if you want QoS applied to a packet during routing, a frame during switching, or a label during multicast label switching. Sorry, not multicast label switching, multi-protocol label switching. A forwarding class, an output queue, and code point bits are mapped to each other and identify the same traffic. The code point bits identify incoming traffic. Classifiers assign traffic to forwarding queues based on the code point bits. Forwarding classes are mapped to output queues. This mapping determines the output queue. Each class of traffic uses on the switch egress interfaces. Next is output queue. Buffers traffic before the switch forwards the traffic out the egress interface. Output queues are mapped to forwarding classes. The switch applies CoS properties defined in schedulers to output queues by mapping forwarding classes to schedulers in scheduler maps. The queue mapped to the forwarding class has the CoS properties defined in the scheduler mapped to that forwarding class. Scheduler map maps schedulers to forwarding classes. Forwarding classes are mapped to queues, so a forwarding class represents a queue, and the scheduler mapped to a forwarding class determines the CoS properties of the output queue mapped to that forwarding class. Traffic control profile configures scheduling for the forwarding class set, priority group, and associates a scheduler map with the forwarding class set to apply queue scheduling to the forwarding classes in the forwarding class set. Extra port bandwidth is shared among forwarding class sets in proportion to the minimum guaranteed bandwidth of each forwarding class set. Forwarding class set, name of a priority group. You map forwarding classes to forwarding class sets. A forwarding class set consists of one or more forwarding classes. All right, perfect. Oh, I think it's fine to go ahead and add that to the notes. I think that was in some way useful. I mean, let's be clear here though, this is for QFX and EFX switches, and this is going to be about MX switches. I don't think there'll be any QFX or EX switches on this entire exam. So unfortunately this probably isn't the best resource. I know there was another guide that wasn't specifically for those kinds of devices. I didn't see it. Oh, here we go. JNCIE-Tech. That looks good to me. Okay, so this looks really good. Let's go through all of these steps, and then that might be the end of this one. I guess I don't really have anything that I'm else that I think really needs to be covered for this. So this can be kind of a quicker one. But it looks like the author of this, the author is Alex, gives some great advice for resources to use. So let's try to do that. So let's see if he actually passed the exam. I mean, not that it makes a huge difference. Like anyone studying for this, even if they didn't pass it, is going to be a decent resource. It's just rare to find other people who have thought about it. Okay, so here we go. We've got plenty of day one books here for quality of service. I think they call it class of service. Yeah. So here's a good one, deploying basic class of service. Yep, so let's okay. Okay, so I'm doing an extract all on this, and I will open it shortly. Okay, so we've got two choices, PDF or a rich text format. I'm gonna go with PDF. Okay, so yep, we've got all of everything we could possibly want to know about CoS. We've got it here. So we're working on scheduling, so here's a whole part of, oh no, sorry, we're working on queuing. I keep thinking we're working on scheduling for some reason. Alright, so that looks fine. Oh, okay, so these are actual courses. Yeah, I'm not gonna be taking those. This looks like a, oh, but here's for, okay, well it is for routers as well. Let's see if there's anything in here for queuing. Okay, so there's all sorts of things for queuing. Yep, so there's just too much. This is a really comprehensive guide. I think it's a valuable resource, but it's just too much for me to go over right now. So let's go note by note to what he's got here, and then we'll call that good for today. Okay, so we're gonna create a unicast BA classifier on router 1. Let's do it on router 2 actually, then I won't need to clean up router 1. Okay, so we can do it on router 2. So let's do edit class of service, classifiers, set, and now we can choose the bits we want. Do we want it at layer 3, layer 2, or applied to an MPLS label? Let's do it at, oh, you know what, that was probably my problem. Wait, I'm confused now. Yeah, because that was probably, so this is actually going to depend on where you put the policy. It's not allowed to be put on a family INET interface if you don't have the correct kind of what is this even called? Bit marking. So let's go with, so what is this, I wonder if this is the p-bit? Let's call it p-bit, assuming that's what it is, or is that INET precedence? Okay, let's do an edit. Okay, set import default forwarding class. Okay, so now we've got to come up with a name. We'll name it my FC. Okay, and we'll do an edit. Oh. What the heck? I'm confused now. Oh, okay. So yeah, and now remember this from the previous reading I did the other day. We've got some default forwarding classes that you don't have to make up, but I'm going to go ahead and make my own. It's going to be called my forwarding class. Okay, and let's set the loss priority. We'll set it to high, and we'll set the code points. Okay, so let's open a set of values. Okay, well, I'm not sure which. Dang it. Oh my god. Okay, so let's go into edit mode if possible. Nope. Nope. Oh, you know what? Let's do this in multiple sets. So we're going to do, the first thing we're going to do is, oh, you know what? But we can't because we've got to apply these knobs to the forwarding class. The loss priority is going to be high. The code points, let's see if we can get some help on code points. Yeah. Okay, and we've got a whole, yep, so here's all the code point aliases. So yep, this is why this is so valuable on the test, learning how to use this help. I don't have to, you know, how would I ever memorize all this? So let's go with AF42. Yep, so it's going to be 100 100, nice and well, now let's go with a palindromic code point. Here we go, perfect. So it's the same read forward as it is read backwards. So it's going to be AF33. Alright, perfect, and the command took just fine, no errors. So before we commit though, we're going to need to apply the classifier to a specific interface. So let's choose the interface we want to apply it to. I'll do a show pipe display set, pipe no more, and so we can apply it to either interface. This is right smack dab in the middle of the topology, so it's got both interfaces configured. Let's apply it to interface 0. But we'll need to, so you're not necessarily going to apply it to the interface, you're going to apply it to the class of service. You're going to apply the interface to class of service. Okay, so set 0, that's 0. Oh. Okay, so now we gotta give it the name of the classifier. I think I made my own name. What did I don't remember what I called it though. So let's take a look at that. Okay, so is this what I called it? Well, oh, I already gave it the name there. Okay, so and then classifier name. So what the, I don't have a classifier name. That's not what I did here. Oh, no, it would be so I gave it a name. The name I gave it is p-bit. Okay, so there we go. Next step is going to be, okay, so this is to apply it to an additional interface. We're just going to apply it to one interface. Oh, okay, and they use a special interface name command? No, they didn't. Okay, I'm not sure what's going on there, but I think things are fine. So let's go up. So we're under Edit Class of Service and apply the EXP classifier to the switch interfaces. System defaults, classifiers, EXP. So let's see, yep, so it's an EXP classifier. So what's the name of it? Let's do pbit. Okay, and now write an EXP rewrite rule. So set rewrite rules, EXP rewrite rule. Oh, rewrite rule name, my rewrite, forwarding class. We'll use the myFC that I did before. Okay, lost priority. This one will do low. Code points. Okay. Oh, we have to do the, so let's do AF33 again, since it is palindromic. Okay, so now we'll need to apply the rewrite rule to the logical interface. Oh! Okay, so you can't use a .0 there, you have to say unit 0. That's fine. Oh! Okay, so I forget what I called the rewrite rule. Oh, I called it my rewrite. There we go. Alright, so next step is going to be the forwarding class configuration. So, here we're just going to be checking our work. So we'll do a show class of service, forwarding classes. Pipe display set relative. Alright, so I don't have that configuration in my candidate config. Let's see if I've got it in my running config. So to do that, I use run show configuration. There we go. Nope, so it's neither in my running config nor my candidate config. So let's add this as part of this configuration. Perfect. Alright, so this looks like it's a QFX feature. It's not going to be on the test, I think. Let me ask the internet. Are QFX devices on the JNCIE? I mean, I shouldn't have to ask the internet, right? Because if I do this JNCIE-SP and then I go to the actual training site and then down to the description of the exam, and it looks like they took out 960. That's no longer being offered, so they don't require. So there's no reason to list the curriculum for it anymore. Yeah, so unfortunately I don't see, here we go. So at the pinnacle of the service provider routing and switching certification track is the one-day JNCIE-SP lab exam. This exam is designed to validate the networking professional's ability to implement, troubleshoot, and maintain Juniper Networks service provider networks. The 6-hour format of this exam requires that candidates build a service provider network consisting of multiple VMX routers. So no QFX, no EX, anything like that. Successful candidates will perform system configuration on all devices, implement various protocols, policies, and VPNs, multicasts, and class of service. So, I mean, I hope there's not a QFX or because it you know, this is a little bit tricky of a wording, because it could be, it requires that you build a service provider network that consists of VMX virtual routers alongside other kinds of routers such as EX and QFX. So I hope they don't get tricky with the wording there, and they're just open and honest with their test takers about what kind of devices are going to be on the test, and it is just VMX virtual routers, nothing else. There's really nothing I can do to, I guess I just kind of have to take them on their word on that, and if I sit down on test day and see a QFX or an EFX, I do have a substantial bit of professional experience on those devices, so I don't think it will really bite me too hard. So yeah, it's just not something worth worrying about, especially to the level where I would go and specifically practice on QFXs and EXs. Okay, so let's change the host outbound traffic egress queue. Okay, so my class, I think I named it. Code points. Oh. Okay, so we're doing DSCP code points right now. I was playing around with the IEEE.1p code points. So we're kind of off on a tangent here, I think. Let's see if AF33 works again. Oh, it still does. Okay. So here's our scheduling. Let's see if everything commits. I doubt it will. I really doubt it will. If it does, I'll be really surprised. Yep, it doesn't work. So duplicate name, network control specified for forwarding class 3 and 4. I can't use the same forwarding class, or I can't use the same name across two different forwarding classes. Each forwarding class must have a unique name. So let's see where I did that. So, Oh, you know what? I think network control is a default name. So I tried to define a new name that was already taken. Yep. So I can't overwrite the default with my own name, because that creates two different policies. I can't get rid of the default one. Not that I would want to. Okay, so I guess I could just change the name of that and see if it commits if I do that. So let's delete this, and we'll say, oh, but I bet you the best effort one would not work then. I guess I'm really not sure what's going on. Class network control, so set Class of service, forwarding classes, class, network control, Q-num7. Okay, well, oh, yep, so let's use a different one. So we'll call it a different one. Okay, and let's see if that fixes everything. So it looks like I was expecting this one. We called that in, but we never defined it first. So I don't know if that was meant to be done later, or yeah, it's meant to be like defined later. But this looks like it's scheduling. It's just something we went over in the past video. So I think I'm kind of happy to move on. It'd be nice if I could find more of a simpler example of the configuration, and just get something really easy going. I guess I could try to match on the. Let's do that. So I'm gonna go back to. Well, first of all, I'm gonna blank. I'm gonna roll back 0. Okay, and then do a show pipe display set, but no more. Okay, so that looks good to me. And now on router 1, I will do the same. I'll blank it out, except for what's required. Okay, so we'll do a rollback 0, or sorry, rollback 1. Show pipe compare. Looks good to me. Show pipe display set, pipe no more. Perfect. Okay, so now I'll try to make that policy again, where if I send a ping from router 4, it will get to router 3, but only if the do not fragment bit is not set. So let's see if we can get that to work. So first things first, do I have router 4 configured? I do. And do I have an IP route? Okay, I do. So let's see if I can ping router 3, and if I can, we'll just keep that going. Okay, so router 3 has an interface, and it's probably interface 1. Well, we should be able to ping the loop back, so let's go with that. Oh, okay, that's the Juniper. So here's, yeah, okay, there we go. There we go. So I can ping the loop back. We don't need to just keep it running, but what I will do is look at the other ping. So we've got this ping with the DF bit not set. So we're also going to be doing this ping that does have the DF bit set, but we're going to write a policy on router 2 to not allow the traffic to go through if the DF bit is set. So firewall. Filter. Okay, so if it's got the do not fragment flag, we're going to toss it out. But like any ACL, especially on junipers, I guess what I'm trying to say is it might be unintuitive when you go to a juniper whether or not it has a deny any, but it is the same on junipers as it is for Cisco's, where if you don't create a permit statement, you have a implicit deny. But it's except on Juniper, it uses different languages. Okay, so that looks good to me. Before I commit it, let's apply it. So we're going to apply it to interface GE000. Okay, so we're going to set family inet, and then it's going to be filter, and it's going to be on input, and it's going to be my filter. Okay, so let's see if this works. It didn't work last time, so I'm not expecting it to work this time. And we can see already it didn't appear to work. So I don't know if the Wireshark capture just wasn't right, or like what the problem was. Let's try a monitor. Oh, I see. Okay, so the commit failed. I think the reason it failed is why it failed last time. This syntax for the fragment flags wasn't accurate. So let's try this. Okay, so it still failed. So we did see that last time 4.0 appeared to work. So let's see if that works again. Oops. Oh, what the heck? See, that's what I don't understand. So let's do a run monitor traffic interface 0.0 matching ICMP. Okay, and then we'll send the okay, so we already did that. Oh, what? Why? Huh. Yeah, that's really confusing. Let's try it just on the regular interface. So it's saying that, oh, let's do no result. Okay, and then we'll do, we'll also do a detail. Maybe some is getting suppressed. Still nothing. So we'll get rid of the matching. Here we go. So now that we no longer have matching, we've got hello packets. We still don't have ICMP registering. Okay, let's try it on the .0 interface. Okay, so it almost looks like ping traffic isn't making it all the way to the other end. And perhaps that makes sense because, well, let's try a trace route. Okay, so it did make it there. Huh. So why is it not showing up on the packet capture? Okay. I thought I knew this before. Like, I thought it would have been a long time ago, but I thought I figured this out. Like, I wasn't seeing ICMP traffic, and I looked into it and figured it out. But I don't know how I figured it out. So this is another OSPF message. We can tell that by the multicast address. So yeah, I'm just not getting any ICMP over monitored traffic. Let's try a quick Google search for that. Yeah, here we go. So monitor traffic doesn't show any ICMP traffic. I'll add this to my notes. So the ICMP responses are handled by the data plane, packet forwarding engine, instead of the control plane. So you won't see it because your monitor traffic only shows you control plane messages. Okay, so you need to have something going to the actual control plane in order to sniff it. So you can't see traffic just traversing through a device using monitor traffic. You can only see traffic whose final destination is that device and is processed by the control plane. Otherwise, it's just seamlessly processed by the packet forwarding engine, and it never even makes it up to the control plane, so there's nothing for monitor traffic to even see. God damn it, which sucks. I want to see the ICMPs. Alright, well, that's good to know. I'm glad I figured that out now and not on the test when I tried to use monitor traffic more extensively and as a replacement for Wireshark, because I would have been very confused on test day. But now I understand, and it looks like there is a pretty simple solution to that. Instead of using pings and trace routes, I can telnet. So even though telnet is not set up, I can use it as a tool to so connection refused by remote host, but we should have gotten a so same deal, it just seamlessly goes through because it's just transiting the traffic. It doesn't get processed by the control plane. We'd have to ping the router itself. There we go. And now we get telnet traffic because the final destination is the actual router, so the control plane of the router has to be involved. Alright, so I think that's going to be it for this topic. I kind of strayed a bit. I tried to work on something I tried to work on earlier, and I ended up getting confused. I tried to do everything here, but I stopped doing it because it looks like he's getting in the QFXs there. So I think, yeah, so that's going to be it. Stay tuned for the next video on rewriting.